University Physics, Volume 1, Chapter 1, Units and Measurements. 1.3 Unit Conversion. Learning Objectives. By the end of this section, you will be able to use conversion factors to express the value of a given quantity in different units. It is often necessary to convert from one unit to another. For example, if you are reading a European cookbook, some quantities may be expressed in units of liters and you need to convert them to cups. Or perhaps you are reading walking directions from one location to another and you are interested in how many miles you will be walking. In this case, you may need to convert units of feet or meters to miles. Let's consider a simple example of how to convert units. Suppose we want to convert 80 meters to kilometers. The first thing to do is to list the units you have and the units to which you want to convert. In this case, we have units in meters and we want to convert to kilometers. Next, we need to determine a conversion factor relating meters to kilometers. A conversion factor is a ratio that expresses how many of one unit are equal to another unit. For example, there are 12 inches in 1 foot, 1,609 meters in 1 miles, 100 centimeters in 1 meter, 60 seconds in 1 minute, and so on. Refer to Appendix B for a more complete list of conversion factors. In this case, we know that there are 1,000 meters in 1 kilometer. Now we can set up our unit conversion. We write the units we have and then multiply them by the conversion factor so the units cancel out, as shown. 80 meters times 1 kilometer per 1,000 meters is equal to 0.080 kilometers. Note that the unwanted meter unit cancels, leaving only the desired kilometer unit. You can use this method to convert between any type of unit. Now, the conversion of 80 meters to kilometers is simply the use of a metric prefix, as we saw in the preceding section, so we can get the same answer just as easily by noting that 80 meters is 8.0 times 10 to the 1 meters. This is equivalent to 8.0 times 10 to the minus 2 kilometers, which is 0.080 kilometers. Since kilo means 10 to the 3, see table 1.2, and 1 equals minus 2 plus 3. However, using conversion factors is handy when converting between units that are not metric or when converting between derived units, as the following examples illustrate. Example 1.2. Converting non-metric units to metric. The distance from the university to home is 10 miles and it usually takes 20 minutes to drive this distance. Calculate the average speed in meters per second. Note, average speed is distance traveled divided by time of travel. Strategy. First, we calculate the average speed using the given units. Then we can get the average speed into the desired units by picking the correct conversion factors and multiplying by them. The correct conversion factors are those that cancel the unwanted units and leave the desired units in their place. In this case, we want to convert miles to meters, so we need to know the fact that there are 1,609 meters in 1 mile. We also want to convert minutes to seconds, so we use the conversion of 60 seconds in 1 minute. Solution. Step 1. Calculate average speed. Average speed is distance traveled divided by time of travel. Take this definition as a given for now. Average speed and other motion concepts are covered in later chapters. In equation form, average speed equals distance divided by time. Step 2. Substitute the given values for distance and time. Average speed equals 10 miles divided by 20 minutes, which is 0.50 miles per minute. Step 3. Convert miles per minute to meters per second by multiplying by the conversion factor that cancels miles and leave meters, and also by the conversion factor that cancels minutes and leave seconds. 0.50 miles per minute times 1,609 meters per mile times 1 minute per 60 seconds. After canceling units and performing the calculation, we find that this is 13 meters per second. Significance. Check the answer in the following ways. Part 1. Be sure the units in the unit conversion cancel correctly. If the unit conversion factor was written upside down, the units do not cancel correctly in the equation. We see the miles in the numerator in 0.50 miles per minute cancels the mile in the denominator in the first conversion factor. Also, the minute in the denominator in 0.50 miles per minute cancels the minute in the numerator in the second conversion factor. Part 2. Check that the units of the final answer are the desired units. The problem asked us to solve for average speed in units of meters per second and, after the cancellations, the only units left are a meter in the numerator and a second in the denominator, so we have indeed obtained these units. Check your understanding 1.2. Problem. Light travels about 9 petameters in a year. Given that a year is about 3 times 10 to the 7 seconds, what is the speed of light in meters per second? Solution. 3 times 10 to the 8 meters per second. Example 1.3. Converting between metric units. The density of iron is 7.86 grams per cubic centimeters under standard conditions. Convert this to kilograms per meters cubed. Strategy. We need to convert grams to kilograms and cubic centimeters to cubic meters. The conversion factors we need are 1 kilogram equals 10 to the 3 grams, and 1 centimeter equals 10 to the minus 2 meters. However, we are dealing with cubic centimeters, where cubic centimeters equals centimeters times centimeters times centimeters. So we have to use the second conversion factor 3 times, that is, we need to cube it. The idea is still to multiply by the conversion factors in such a way that they cancel the units we want to get rid of and introduce the units we want to keep. Solution. 7.86 grams per cubic centimeters times 1 kilogram per 10 to the 3 grams times 1 centimeter per 10 to the minus 2 meters, quantity cubed. After performing the necessary calculations and unit cancellations, we get a final answer of 7.86 times 10 to the 3 kilograms per meters cubed. Significance. Remember, it's always important to check the answer. Part 1. Be sure to cancel the units in the unit conversion correctly. We see that the gram in the numerator in 7.86 grams per cubic centimeters cancels the grams in the denominator in the first conversion factor. Also, the 3 factors of centimeters in the denominator in 7.86 grams per cubic centimeters cancel with the 3 factors of centimeters in the numerator that we get by cubing the second conversion factor. Part 2. Check that the units of the final answer are the desired units. The problem asked for us to convert to kilograms per cubic meter. After the cancellations just described, we see the only units we have left are kilograms in the numerator and 3 factors of meters in the denominator, that is, 1 factor of meters cubed, or meters cubed. Therefore, the units on the final answer are correct. Check your understanding 1.3. Problem. We know from figure 1.4 that the diameter of Earth is on the order of 10 to the 7 meters, so the order of magnitude of its surface area is 10 to the 14 meters squared. What is that in square kilometers, that is, kilometers squared? Try doing this both by converting 10 to the 7 meters to kilometers and then squaring it, and then by converting 10 to the 14 meters squared directly to square kilometers. You should get the same answer both ways. Solution. 10 to the 8 kilometers squared. Unit conversions may not seem very interesting, but not doing them can be costly. One famous example of this situation was seen with the Mars Climate Orbiter. This probe was launched by NASA on December 11, 1998. On September 23, 1999, while attempting to guide the probe into its planned orbit around Mars, NASA lost contact with it. Subsequent investigations showed a piece of software called SM Forces, or Small Forces, was recording thruster performance data in the English units of pound-seconds. However, other pieces of software that used these values for course corrections expected them to be recorded in the SI units of Newton seconds, as dictated in the software interface protocols. This error caused the probe to follow a very different trajectory from what NASA thought it was following, which most likely caused the probe either to burn up in the Martian atmosphere or to shoot out into space. This failure to pay attention to unit conversions cost hundreds of millions of dollars, not to mention all the time invested by the scientists and engineers who worked on the project. Check your understanding. 1.4. Problem. Given that 1 pound is 4.45 newtons, were the numbers being output by SM forces too big or too small? Solution. The numbers were too small, by a factor of 4.45. This concludes 1.3 Unit Conversion of Chapter 1 Units and Measurements from University Physics, Volume 1. Hit the like button and remember to subscribe. Special thanks to the OpenStax team for creating this free, online resource.